I can see a couple ways of doing number 24. Here's one way. First of all, I've got two powers with the same base, 5x, so I can just add those exponents, right? We're multiplying, so I can add these exponents. So I could write this like this, 5x to the 6 plus 4, giving us 5x to the 10th, and that's probably good enough. Or I could actually do this. Since it's a multiplication inside, I could distribute that. I don't think that's what the book has in mind for us doing here. 5 to the 10th, x to the 10th. Probably not. I think this one here is probably good enough. And number 25, again, we've got a multiplication with two powers of the same base, right? Got two bases being negative 4x. So all I have to do is add the exponents. Now keep in mind, there's really a 1 here, right? So when we do this, we're going to get negative 4x. Actually, let me write it so I can read it. Negative 4x to the 2 plus 1. That gives us negative 4x cubed. Let's see what we can do here. Now, inside, I'm raising something to a power, right? To the second power. I got this thing to the second power, and all I have inside is multiplication. So we can distribute this 2 to each one of these numbers. Goes to the 3. Don't forget the 3. Sometimes it's easy to forget the constant. So I can write this as 3 squared, and then actually a to the 4th squared, and then actually b to the 5th squared. And then 3 squared, that's a 9. We can write that. And then what about this? You have a power to a power. So I have a power to a power. When I'm raising a power to a power, I multiply the exponents. So this becomes a to the 4.2, b to the same thing here, 5.2. So this gives me 9, a to the 8th, b to the 10th. Now, if you can do this, and after you do a few of these, you probably will, you can go directly from here all the way down here. Here's what you're going to see. 3 squared, 9. And then you know what to do with these. So you have powers to powers, you're going to multiply the exponents. So you just do it directly. So you can skip these steps and just go from here to here. 4 times 2 is the 8. 5 times 2 is the 10. Now, let's simplify this. I'll simplify each one separately. So we're raising powers to power, so I'm going to multiply those exponents. So this will give us y to the 10, y to the 12th, right? I just went ahead and multiplied. And now I've got two powers with the same base. So then I'm going to add those exponents, right? We're going to get y to the 22nd. So first up, we multiplied, getting the 10 and the 12, and then two powers of the same base we added, getting the 22. And let's put this up here too. We got a multiplication here. I've got this times this, but each one of these are raised to a power. So what are we going to do here? Well, we know we're going to multiply the exponents. What are we going to do with these negatives? Well, look at this. We have a negative 4 times, right? So if you have a negative being multiplied 4 times, that's going to be a positive. So this term is positive. But what about this one? You have a negative 3 times. So an odd number of negatives is negatives. Even number of negatives is positive. So I have a positive times a negative. That gives me a negative. And then let's multiply the exponents. So we're going to have x to the, now right here, multiply those exponents. We'll get 12. Y to the 20, multiply the exponents, times x to the, 2 times 3 is a 6. Y to the 4 times 3 is 12. Now I've got x to negative, x to the, what have we got? X to the 12 times x to the 6, right? Two powers with the same base. This is all a multiplication. The order doesn't matter. X is the base, x is the base. I'm multiplying, I'm going to add these exponents. So I'm going to write it this time, 12 plus 6, and then y to the what? 20 plus 12. Y to the 20 plus 12, so we'll get negative x to the 18, y to the 32.